Okay, students, Ms. Whitaker here, and I just wanted to go over the percent review so you'd have something to study over the weekend. We've learned a lot in the last week about percents, a lot of formulas mainly. I'm going to go ahead and write those formulas right here just so you can write those down, have that on record. Just you need to really memorize these things. The main things we're going to be working with percents is the fraction decimal percent conversion. You're going to need to know how to do that. But we've done that for at least 2 years now, so you should be familiar with fraction decimal percent conversions. So a fraction to a percent, we would put that, we would try to make a fraction over 100, or we could do top in, bottom out, change it to a decimal, and then change that decimal to a percent. Decimal to a percent, we're just going to move it 2 to the right. From percent to decimals, 2 to the left. From percent to fraction, percent means per 100, so we're going to put that over 100 and reduce. So make sure you know how to do the conversions. The other one is the proportion. That's the percent over 100 equals is over of, which is the part of the total. That 100% goes with the total, and that percent is the part that we're looking for. So you need to know the proportion. Another thing we learned was the percent of change formula, which was the amount of the change over the original amount, and then it's just a division problem. We're interested to know what was the percent of the increase or the decrease. That's the change. So how much was that out of the original amount? So this is the formula that we're going to use for that. So make sure you know all these different ways to do this. We also talked about multiplying by the decimal equivalent. If you're just looking for percent of a number, you can do the proportion, but you can also multiply by the decimal equivalent to that percent. So just this is the bottom line formulas and concepts that we're looking at for this test. So make sure you're familiar with all these formulas. All right, let's look at our review, starting with number 1. A percent change describing an increase in a quantity. So increase is your keyword there. So that's going to be E, the percent of the increase. A percent change describing a decrease. That means it's going down. So that's going to be D. And then a ratio comparing a number to 100 is going to be a percent. So that's going to be B. A ratio comparing a number to 100. So out of 100 is your percent. All right, let's take a look at number 4. It says write the percent modeled by the grid. Now this can be also used in your, when we're talking about decimals, it could be a decimal grid, but it also is a percent grid because percent means per 100. We have 100 little squares in this grid. The whole thing is one whole or 100%. So if each little square is 1/100th or it's 1%, we just need to count what's shaded here. I know that there's 10 in a row, so there's 10, 20, 30, 40, 41, 42, 43, 44, 45 out of 100, and I'm supposed to write the percent, so that is 45%. If this was gone all the way down, that'd be half of it, so that'd be 50%, but this is 45% of the whole. Number 5, write 54% as a fraction in simplest form. Percent means per 100. So I'm going to write 54 over 100, and then I'm going to reduce. Let's just do the easy one. They're both even, so let's just divide by 2. That would give me 27 on top, and then that would give me 50 on the bottom. And I'm trying to think, I don't think I can go any farther than that. There's nothing that's a common factor for 27 and 50, so I'm done, and that's my answer. That's in simplest form. Please make sure you do that. All right, let's go to the next page. Some more conversions. You've got to know how to change these. Number 6 says write 33% as a decimal. It's easy to go from percent to decimal because it's only about moving it 2 to the left, because 33% means 33 hundredths, and if I'm going to write that as a decimal, it's going to look just like that. I'm just moving it 2 to the left. So 30.33 is your answer. Now think about the big picture. 33% is about a third of a whole. 0.33 is about a third of the whole. So make sure it makes some sense. Now look at this one. You have to look at logic. When you look at something like number 7, it says write 3.37 as a percent. Now this is more than 3 wholes. So if 1 whole is 100%, then 3 wholes is going to be 300%. And again, we're just moving the decimal twice now to the right to change from decimal to percent. So this is going to be 337%, which makes sense. This is more than 3. This is more than 3. So keep that straight. All right, number 8, 0.93 as a percent. Again, move it all the 2 to the right. So that's going to be 93%, which makes sense. 0.93 is almost the whole thing. 93% is almost the whole thing. Write 7/10 as a percent. We can do this a couple of ways. We can get a fraction out of 100, and I can easily do that. 10 to 100 is times 10, so 7 times 10 is 70, so that's 70%. Or I could do top in and bottom out and get 0.7 as my decimal, and then move it 2 to the right and get 70%. So 7 out of 10, 70%, 0.7, make sure it all makes sense that they're equivalent. All right, let's look at number 10. We get down to taking what we know about percents and applying that to real-world problems. A compound is made up of various elements totaling 90 ounces. A compound means it's made up of several different things. If the total amount of uranium in the compound weighs 18 ounces, what percent of the compound is made of uranium? So it's saying in this compound there's a whole bunch of different elements, and the total of the elements is 90 ounces, and it says the uranium is 18 of that 90, and as we've talked about before, I can write that as a ratio. So 18 out of 90 is uranium out of the total. So I'm looking for the part of the total. I'm looking for that percentage. So I could do this is my is over of, and I could be looking for the percent out of 100. So I could do it that way. Or I could just do top in and bottom out, change it to a decimal, and then move it 2 to the right. So I think I'm going to go ahead and do that. 18 divided by 90 is 0.2. I'm going to move that 2 to the right, and that's going to be 20% for my answer. Now I could have also done 100 times 18, that's 1800, and then divide by 90 to get the same answer. All right, number 11, during the weekdays, Tom finished 84% of his weekly chores, and Kim completed 9/10 of hers. Who must finish a greater percent of chores during the weekend? That means during the week, Tom finished this much, Kim finished this much. Who has more to do on the weekend? So don't get that confused of who's done more. It's who has more to do. So let's change either this one to a fraction to compare with this, or I would actually change this to a percentage. She did 90%. That's the same thing as 9/10. And Tom did 84%. So it looks like Tom has got more to do. He's got 16% left to do, and Kim's only got 10% left. So Tom at 16% is your answer. All right, and number 12, use a fraction to estimate 8% of 62. I'm going to change that to 10%, which is 1/10 of, let's just make it 60 because we're estimating. So 1/10 of 60 is 6, and I'm done. Estimation means make it easy for me. All right, so we've got a couple of shoe stores. They both sell these certain kind of shoes, the Quick Runner shoes. ABC Shoes sells them for $60.05. Low Price Shoes sells them for $38.85. But today, the first store, ABC, decides to offer a 30% discount, and it's saying which store offers the better deal. So what I'm going to do is I'm going to use the nifty little 10% rule that we learned, and I'm going to say this is about $60. I'm going to do 10% for, this is for ABC. 10% of $60 is 6, and I'm going to do it 3 times because it's a 30% discount. So I'm going to take $18 off of 60. So if I take $18 off, that turns their price into $42. So the new price for ABC is $42, but it looks like Low Price still has the lowest price. So which store offers the better deal? Low Price still beats, even with ABC's 30% discount. Low Price still has the better deal. And that's what we're looking for when we're shopping. We want to make sure we're getting the best deal. All right, number 14, we got bicycles, and they're selling this Ultra Extreme X mountain bike for about, let's say, about $180. Let's just change that. It's 2 cents away, so let's just do that, and that's bottom line anyway. Cami Cycles sells the same bike for $280.20, so about $280. Today, Cami Cycles decides to offer a 19% discount. Which store offers the better deal? So let's change that to 20%. Let's see if it's far enough away that we can just do some quick estimating, but not too far from 19%. So let's do 20% of 280. And I'm going to do 10% twice. 10% of 280 is 28. I'm going to do that twice. So that becomes 56. So I'm going to take 56 off of 280. And I'm still high above $200. That's going to be $224. So Cami's now at $224. And what was the other one? Eddy Cycle, they're doing it for $180. So who has the better deal? Eddy Cycle for sure. They're way low, like about $40 lower. So that's going to be your answer for number 14. All right, number 15 just says use 1% or 10% rule to estimate 93% of 149. All right, so estimate here. I'm going to use obviously the 10% rule because it's 93. I'm going to change that to 90. And then I'm going to change that to 150. So I'm going to do 10% of 150. And I'm going to do it 9 times. 10%, we're just going to move it 1 over to the left. It's 15. I'm going to multiply that by 9. And I get 135. Now, does that make sense? Almost the whole thing out of 149 is 135. Yes, that makes some sense. So make sure you're using your common sense and logic when you're answering and making sure that you know what a percentage is. 90% is not 90. It really is 9/10 of something. So here was the number we're working with, which is about 150. So as long as we're estimating, as long as we're in the ballpark, you're good. All right, so I'm going to stop here, and then I'll continue with the next video on doing the problem 16 through 30.